This is Unit 6, Radicals, and we're solving radical equations. Remember, with equations, whatever you do to one side of the equation, you must do to the other. So, first things first. Number 1, we have the square root of 86 minus 7a is equal to a minus 6. To get rid of the radical, we have to square it, which means we must square the other side. We cannot just square the a and square the 6. We must square the expression. That means over here that this is a minus 6 times a minus 6. You get a squared minus 6a minus another 6a plus 36. There's your minus 12a. Now, once you have that, you're going to subtract 86 from both sides, and you're going to add 7a. Notice it's 7a, not 7a squared. Now you've got this very nice quadratic that you can factor. You factor it to a minus 10 and a plus 5. You get that a equals 10 and a equals negative 5. However, you have to plug these back in. You can't have negative answers here. So if I get the square root of 86 minus 7 times 10, this is the square root of 16. Great, that works because it's equal to 10 minus 6, which is 4. So that all checks. That's great. Now, if I do the other one, it's not that a negative doesn't work, but I don't get the right answer. If I put in negative 5, I get the square root of 86 minus 7 times negative 5 is equal to negative 5 minus 6. This is the square root of 86 plus 35 is equal to negative 11. This is the square root of 121 is equal to negative 11. But notice, this is asking for the principal or positive root. So that one doesn't work. Number 2. Again, you have to square both sides. Squaring both sides, don't forget to FOIL. Okay? Then add your 5n to both sides and subtract your 39. You now have a trinomial that you can factor. Factors of negative 14 that add to negative 5 are negative 7 and 2. That means n is 7 or n is negative 2. You have to check them. Notice this is the square root. It's asking for the positive square root. If I put a negative in, it's not going to work. I can then check the 7, and it does, in fact, work. Okay? Number 3, before you do anything, isolate the radical. So I'm going to divide both sides first by negative 3. Then I'm going to square both sides and multiply both sides by 2. N is 50. If I plug 50 in, negative 3 times the square root of 50 divided by 2 equals negative 15. This is negative 3 times the square root of 25. That's negative 15. It's equal to negative 15. It checks. Number 4. Here you've got x to the 2/3 plus 3 equals 30. I believe my little indication there is I changed that, just so you know. You have minus 6. So the first thing I did was I added 6 to both sides. It's a square root, okay, where it's x to the 2/3. So remember that x, this is power, and this is root. So what I need to do is I need to take the square root of both sides. That gives me x to the 1/3 is equal to 6. Now I'm going to cube it and I get 216. Number 5, get the radical by itself. So add 1 and add x. That'll give me x plus 4 is equal to the radical. Now I'm going to square both sides, making sure that I FOIL. Then I'm going to gather all my terms on one side. And then I'm going to factor, and I get x equals -1. When I plug this in, if I check, I get 3 is equal to -1 minus 1 plus the square root of 6 times -1 plus 15. 3 is equal to 1 minus 1 plus the square root of 9. 3 equals 3. Bingo! It checks. Oh, big kahuna over here. We got the big Sharky. This becomes a little more difficult here. Because this, when I have a radical and another radical like this, I'm going to have to square it twice. So, first things first, I isolate one of the radicals. Get one of them by themselves. Then when I square it, okay, this one comes out from underneath. This, this right here, remember I have to FOIL it. So 1 times 1 is 1. Then I get a root 1 minus v and a root 1 minus v. That's where I get the two of them. And then this times itself, it comes out. Now, before I do anything else, I'm going to simplify. 1 plus 1 is 2. Then I have the minus v, and I have the 2 times the radical. I'm now going to move all of my terms except for the radical. I'm going to isolate the radical again to the other side. So I subtract 2. I add v. 1 minus v is equal to 2 square root of 1 minus v. If both of these terms were divisible by 2, I would divide by 2. Since they're not, I'm simply going to square the right and square the left. I can distribute the 2 because these are multiplied, not added. So now I'm going to FOIL the left, and on the right, I'm going to get 4 times what's underneath the radical. Now I've got to distribute the 4, and then finally move things over, factor, and I get my answers. Then I can check my answers to see if they both work. And I've got, if I check the -3, I get 3 minus 2 times -3. That's 3 plus 6. So that's the square root of 9, which will be 3. 1 minus -3. It's going to be the square root of 4, which is 2. And that does equal 1. Then I can take the 1. 3 minus 2 is 1. And then I've got minus 1 minus 1 is 0, so 1 is equal to 1. So both of them work. You do have to check because you might introduce extraneous results. The last two here. Number 7. Always take out the i's first. So this guy becomes I root 15, I root 15, I root 15. Now gather your i's together, and I get I cubed. Square root of 15 squared times 15. I put 2 of the 15s together. That means I can take one of the 15s out, and remember that I cubed reduces to -I, and you still have a root 15 inside. Putting it all together, -15I root 15. These two are the same, but this is the preferable way to write it. Number 8 looks crazier than it is. They're both cube roots. If they are both cube roots, then all I need to do is cube both sides. This is actually the easiest one. Cubing both sides means I get rid of the radicals. 2x minus 9 equals 3x plus 20. That is a basic algebraic multi-step equation. I subtract x from both sides, and then I subtract 20 from both sides. -29 is my answer. Remember that you can take the odd root of a negative number, so it's okay. So you're going to get the cube root of 2 times -29 minus 9 equal to the cube root of 3 times negative 29 plus 20. If you put those into your calculator, just 2 times negative 29 minus 9, you're going to get the cube root of 67. If you do 3 times negative 29 plus 20, you will get the cube root of negative, so there should be a negative there, 67. You can take the cube roots of negative numbers and it checks. That's all there is to solving radical equations. This is Objective 4 from Unit 6. Good luck on that test.